Hello, for this lesson, no, we will be talking about indeterminate forms and L'Hopital's rule. So before we proceed with the discussion proper, no, let us have a quick review. So we have, let's say, a function f of x is equal to k over x over k. So let us have k constant, no? Let's make k a constant. So what's the value of the function when x is equal to 0? So we have, let's say, f of 0 is equal to 0 over k, and we all know that this is equivalent to 0. Right? So, this is our answer. And paano kapag kabaliktad? No? F of x is equal to k over x. So, we have f of 0 is equal to k over 0, which is equivalent to undefined. Diba? Any number divided by 0 is undefined. So, etong dalawang to, no? So, this is what we call determinate and indeterminate forms. No? So, let us first talk about determinate forms. No, a function is said to be determinate if the operation involved yields to a number or single number value or to infinity. So here are some of the determinate forms. No, so say 0 plus 0 or 0 minus 0 is 0, obviously. Diba? 0 times 0 is also 0. Let me change the color. Infinity times infinity is also infinity depending on the sign. Diba? K divided by infinity, no? So say let's have an example. Let's say I have a pizza here, no? Kunwari, may pizza ako diyan. Ayan. No, so kunwari hatiin natin yung pizza into 1, no? So I mean mahati tayo ng 1 time. So with that, no, magiging dalawa na. So dadami. So we have, let's say hatiin ko pa ulit ng isa pa. So, magiging 4, di ba? 1/4 per piece. And if we're going to divide this infinite times, no? Ihatiin natin yung ating pi infinite times. Ilan na may iiwan? Di ba? So, as we all know, wala na may iiwan. Di ba? Madudurog ng sobra yung pi natin. So, hence, k divided by 0 or k divided by infinity rather is equivalent to 0. No, so next we have infinity divided by k. This is still infinity kasi hindi naman natin alam gaano kalaki yung infinity. So infinity divided by a constant is infinity. No, so then we have k times infinity. This is equivalent to infinity. However, k should not be equal to 1. Ito 'yon. It should not be equal to 0. No, so ito 'yon. Yung condition natin for this. So then we have 0 raised to infinity. So this is equivalent to 0. Okay. Then we have k raised to infinity. This is equivalent to infinity. Okay. And we have infinity raised to infinity. This is equivalent to as well infinity. No, so yan yung mga determinate forms natin. Kaya kay k raised to 0 din pala, no, we have a restriction. Ang may restriction natin is this one and this one. So ito yung restriction natin, no. So take note that for k times infinity and k raised to infinity, k should not be equal to 0 and 1 respectively. So, yun yung mga limits natin. Bakit? Kasi if this is the case, no, this will become indeterminate. No, so, a function is said to be indeterminate when the involved operation does not yield to a single value or infinity. No, nagkakaroon ng tinatawag natin na contradiction. Kasi remember, in mathematics, there should only be one answer to certain values or certain propositions, 'di ba? So for example, we have 0 raised to 0, no? So alam naman natin na ang n raised to 0, 'di ba, this is always equivalent to 1 regardless of the value of n. And if we have 0 raised to n, this is equivalent to 0. And if we're going to plug, no, yung each other to one another, so 0 raised to 0, hindi natin malalaman kung 1 ba yan or 0 ba yan. Diba? So, that's one example of indeterminate form. Then, we have infinity raised to 0. No? So, infinity raised to n is also equivalent to infinity. No? So, and n raised to 0 is 1. No? So, hindi natin malalaman kung 1 ba yan or infinity ba yung sagot natin. 1 raised to infinity, ganun din. No? So, 1 raised to n is always equal to 1. But, number raised to infinity is also equivalent to infinity. Diba? So, hindi natin malalaman kung saan ba siya papunta. Converging ba siya towards 1 or converging ba siya towards infinity. No? So, 0 divided by 0, ganun din, no? Same rule, no? So, Yan yung mga indeterminate forms natin. Infinity divided by infinity, hindi naman kasi natin alam what is the exact value of infinity. So we cannot tell na, hindi naman natin pwede sabihin na infinity minus infinity is still infinity. Kasi paano kung equal yung infinity? Then that will be equal to 0. No? So yun yung mga indeterminate forms natin. Then we have 0 times infinity. No? Hindi natin masabi kung 0 or infinity ba. And infinity divided by infinity. So, yan ano. So, that is for the indeterminate form. So, let's have limits of a function. No? Review tayo ng kaunti sa limits of a function. So, we know that the limit of the function f of x over g of x when as x approaches k, no, substitute lang natin yung kkx. Then, we will have our f of k over g of k. But, paano kung yung f of k over g of k natin is equivalent to 0 over 0 or infinity over infinity. No, so doon pumapasok yung tinatawag natin na L'Hopital's rule, no? So denoted by equals raised to h, no? So that's L'Hopital's rule. For a limit, no, as f of x over g of x as x approaches k of the indeterminate form 0 over 0 and infinity over infinity. Actually, hindi lang dito restricted but on all indeterminate forms. But ito yung mainly na ginagamitan natin. So, the limit f of x over g of x is equivalent to the limit f of x, f prime of x over g prime of x. Okay? If the limit, no, ito, if this exists or equal to positive or negative infinity. No? So, yan, no, makukuha natin yung sagot ng ating nung limit natin, no, by getting the derivative of the numerator and the denominator. So, reminders on applying the L'Hopital's rule. There may be instances that we will need to apply the rule multiple times, but we must confirm that the result is still indeterminate before applying again, no, yung rule natin. Then, L'Hopital's rule is also valid for one-sided limits and limits at infinity. No, so we have here our example. Let's say, evaluate the limit of the function x squared minus pi over 2 over sine x as x approaches pi. No, so let's substitute. So we have pi squared minus pi squared over sine pi. And we all know, diba, this is equivalent to 0 over sine pi is also equivalent to 0. So hence indeterminate, no, yung ating limit. So let's get the derivative, no? So we have the limit as x approaches pi, no, of x squared minus pi squared over sine x. So, let's get the individual derivative, ha? Tig-isa. So, d over dx at saka d over dx. Ayan. Okay, so the derivative of x squared minus pi squared, this is equivalent to as x approaches pi, this is equivalent to 2x over, diba, plus 0. So, over, the derivative of sine x is cosine x. Okay, then let's get the value. No? So, substitute na natin ulit. So, we have 2 pi over cosine pi, that is negative 1. Diba, which is equivalent to negative 2 pi. Or approximately, this is equivalent to negative 6.28 something. No? So, let's validate, no, yung nakuha natin na sagot. So, pero ang sagot natin dito is negative 2 pi. No, so let's apply yung rules natin sa limit by using calculator. No, so ayan. Wait lang ha, palabasin ko lang yung calcul natin. So, paano natin i-check? No? So, let us use yung one-sided limit, 'di ba? Yung nagdadagdag ng very small amount of change. So, or nagbabawas. Say, the limit as x approaches pi plus, let's say, 0.0001, no? Ayan. X squared minus pi squared over sine x. So, let's just use the calculator, no, to validate L'Hopital's theorem. So, we have, palabasin ko lang yung calcu, ayan. So, we have This is alpha x squared. Oh, sorry. Alpha x squared minus shift exponent squared. Diba? Over sine alpha x. Then use calc. Okay. Then we have pi plus 0.0001 equals, ayan. So we have negative 2.831. No? So approximately, this is equivalent to 6.28, ano yan? 283. Say, no? So nearly negative 2 pi, no? So yun yung proof natin for L'Hopital's theorem. Okay? So, ganun lang, no? Individual derivative, hindi tayo mag-apply ng quotient rule. So, isang derivative sa numerator, isa sa denominator, then apply the limit. Okay? Then, let's have our second example, no? So, we have here, evaluate the limit of secant x minus 1 over sine x as x approaches 0. So, ano muna natin, no? So, try muna natin i-solve. So, we have here the limit as x approaches 0 of 1 over cosine x, diba yun yung secant natin, minus 1 over sine x. So, we have 1 over cosine 0 minus 1 over sine 0. Cosine 0 is 1, diba? 1 over 1 minus 1, that is equivalent to 0. Sine 0 is equivalent to 0. So, therefore, we have an indeterminate answer, no? So, let's get the derivative. So, we have the limit of the derivative of secant x is secant x tangent x squared, tangent x, sorry, minus 1 over cosine x. Diba? So, as x approaches 0. So, this is equivalent to 1 over cosine x times sine x over cosine x minus 1 over cosine x. Diba? So, this can be simplified to sine x over cosine squared x minus 1 over cosine x. Diba? Then, substitute na natin si 0. No? So, we have sine 0 is 1. Sine 0 is 0 over cosine squared x. Cosine 0 is 1. So, that is squared. Minus 1 over cosine 0, which is equivalent to 1. No, this is equivalent to 1. So, therefore, we have 0 minus 1 over 1. And hence, we have negative 1. Ayan. So, this is the answer to our limit, no? So, by using L'Hopital's theorem. Okay, so I'll leave the proof to you. So, ganun pa rin, no? So, just type it in the calculator. 1 over cosine x minus 1 all over sine x. Then, as x approaches 0 plus 0.00001 for very small change, then you'll arrive with an answer near negative 1. No, so not exactly negative 1, but near, very, very near to negative 1. Okay, then we have here our third example. Let's have the limit of the function cosine x over x squared as x approaches 0. So, we have cosine 0 over 0 squared, which is equivalent to cosine 0 is 1 over 0 is undefined. Diba? So, since undefined, no, let's apply L'Hopital's rule, no? So, we have the limit as x approaches 0 of the derivative of cosine is negative sine x over 2x. Diba? So, substituting, so we have negative sine 0 over 2 times 0. Sine 0 is 0, no? So, over 0. So, still undefined, no? Ito yung sinasabi natin kanina na we can apply multiple we can apply multiple L'Hopital's rule, no? So, we have the limit as x approaches 0, no? So we have the derivative of negative sine x is negative cosine x. The derivative of 2x is 2. So we'll have negative cosine 0 over 2, which is equivalent to what? No, we have negative 1 over 2. Ayan. So this is our answer. No, so you can check it using the calculator, no? So para ma-validate natin yung sagot natin sa Rolls theorem, sa L'Hopital's rule. Sorry, nalilito. Ayan. So hindi lang naman I mean katulad ng third example natin, 'di ba? Hindi naman diretso na 0 over 0 yung nakuha natin. So L'Hopital's rule for other indeterminate forms, no? A function may not be explicitly be in the form of 0 over 0 or infinity over infinity. You may want to check if the functions may be rewritten in the forms that are acceptable to L'Hopital's rule, no? So pwede tayong mag-manipulate ng mga values natin, ng mga functions natin, then kapag na-manipulate na natin and na-prove natin na 0 over 0 yung lalabas, then we can apply L'Hopital's rule to the rewritten function. No, so just like with this one, we have evaluate the limit of the function x, ln x as x approaches 0 from the right. No, so from the right yung ano natin dito. So how can we have this one? So obviously hindi siya 0, I mean hindi siya f of x over g of x, 'di ba? So why not let's try to transform, no, our given. So I will multiply 1 over x over 1 over x para ma-cancel to at saka ito, 'di ba? So therefore we have ln x over 1 over x, 'di ba? So this is the limit as x approaches 0 from the right, no, of ln x over x raised to negative 1. No, so let's try to solve. No, ln 0, pwede nyo siyang gawin ganyan na lang, no? Disregarding the plus sign. So 0 raised to negative 1. So we have 0 over 0, or rather undefined, no, not 0, but rather undefined. Undefined over 0. No, so both undefined, no, so hindi pwede yan. So let's apply L'Hopital's rule, no. So we have the limit as x approaches 0 from the right. The derivative of ln x is 1 over x, 'di ba? So over the derivative of x raised to negative 1 is negative 1 over x squared. Okay? So simplifying, this is equivalent to 1 over x times negative x raised x squared, no? So this will cancel. Ayan. So therefore we have negative x. Okay, so as x approaches 0, no? So as x approaches 0, we have negative 0 or simply 0. So the limit is equivalent to 0. Ayan. No, so ganun na, no? So hindi porket hindi siya naka-form ng fraction, hindi na natin siya pwede i-solve, no? So we can manipulate the given para maging fraction siya, magmukhang fraction. Then we solve, no? So ayan. Okay? So we have our last example. Is it last example? Hindi pa pala. Last two. No, so sorry, this is the same. Yeah, we already have our last example. So we have here the limit of the function x raised to 1 over x minus 1 as x approaches 1 from the right. No, so paano natin i-solve to? No, so say y, no, or sige, a na lang. A is equivalent to the limit as x approaches 1 from the right ng x raised to 1 over x minus 1, 'di ba? So let's apply natural logarithm. So you have ln a is equal to ln of the limit as x approaches 1 from the right ng x1 over x minus 1. Okay, so, di ba alam naman natin na pwede natin ipasok si limit dito sa loob. Di ba? So, this will become the limit as x approaches 1 from the right ng natural logarithm ng x raised to 1 over x minus 1. Okay? Then, applying the properties of logarithm, if we have ln a raised to b, this is equivalent to b ln a. Diba? So, we have the limit as x approaches 1, no, of 1 over x minus 1 multiplied to the natural logarithm of x. Okay? Then, diba, this can be rewritten as the limit as x approaches 1 from the right of the natural logarithm of x over x minus 1. So, let's apply, no? So, we have, huwag nyo muna pansinin yung LNA, no? Basta alam natin na LNA yung dulo. So, this will be ln of 1 over 1 minus 1. ln of 1 is 0. Over 1 minus 1 is 0. So, we have an indeterminate form. No? So, ayan. Let's apply L'Hopital's rule, no, for this limit. So, we have the natural logarithm of a. A is the answer that we are looking for. Diba? We have the limit as x approaches 1 from the right ng ln x over x minus 1. So, let's apply the derivative. So, we have ln a is equivalent to the limit as x approaches 1 from the right. The derivative of ln x is 1 over x. Diba? Over the derivative of this is 1. No, simply 1. Or simply 1 over x. So, let's substitute. So, we have ln a is equivalent to the limit as x approaches 1 from the right of 1 over x. ln a is equivalent to 1 over 1, which is equivalent to 1. No, so we have ln a is equal to 1. And we did not need ln a, but we need only a. So what are we going to do? No, so if you can remember, e raised to ln of a, this is equivalent to a. And if we have ln of e, or rather, ln of e raised to a, this is also equivalent to a. So, ito i-apply natin na theorem. So, we have to raise both terms with e. I mean, make both terms as exponents of e para ma-cancel natin to. So, therefore, a is equal to e. No, e is the limit of the function, no? Itong ating function na x raised to 1 over x minus 1. Okay, as x approaches 1 from the right. Okay, so this is our answer. Okay, this is roughly what's the value of e? Alpha exponent. Ayun, 2.7718. No? Ayan. So, roughly, yan yung kanyang equivalent. Okay, so let's check, no? Para baka mamaya isipin magic lang ginagawa natin dito. So, let me bring out my calculator. No, apply natin yung ginagamit natin kanina, no? So, we have here our function. Our function x raised to 1 over x minus 1. Alpha x minus 1. So, sabi nga natin, no, let's use calc. Tapos, 1 plus 0.0001. So, therefore, we have 2.718. No, para ma-check natin kung talagang, ano siya, tama, di ba? Ito yung sagot natin, e. Di ba? Divide natin by alpha e. Dapat, dapat 1 yung lalabas or near to 1. No? So, we have 0.99995, which is almost equivalent to 1. So, therefore, our answer is correct. So, ayan. Ba ko lang yung calculate. Yan. So, that's for L'Hopital's rule, no? And indeterminate forms. I hope you guys learned something, no? So, next topic, we will be talking about the differential. Okay, so thank you for listening and God bless.